In this problem, we want to show if a plus b plus c is 0, the following expression holds. If you want to solve the problem yourself, please pause the video. This is one of those problems that if you just do the math, you can solve it, but there might be a slightly more innovative way to solve this, which I will explain in another video. But for now, let's just do the math and see how it will turn out. It will be easier to simplify the expressions in the two parentheses separately. So let's call the first parenthesis P and the second parenthesis Q. So we want to find the least common denominator for P. Therefore, the numerator will be A times C minus A times A minus B plus B times B minus C times A minus B plus C times B minus C times C minus A, and the denominator will be B minus C times C minus A times A minus B. Now, if we start to expand the numerator of P, we will get A times CA minus CB minus A squared plus AB plus B times AB minus B squared minus AC plus BC, and the last term will be C times BC minus AB minus C squared plus AC. And let's leave the denominator as is, B minus C times C minus A times A minus B. And then we can further expand the numerator of P to get A squared C minus ABC minus A cubed plus A squared B plus AB squared minus B cubed minus ABC plus B squared C plus BC squared minus ABC minus C squared plus AC squared. We still don't touch the denominator and keep it as is. Let's simplify the numerator a little bit more. Let's put all the terms, all the cubed terms in one parenthesis. So a cubed, b cubed, and c cubed with the sign of minus, and then we have three ABC terms. So minus 3ABC, and then we can factor out a squared from the terms a squared c and a squared b. So we will get a squared times parenthesis b plus c. Then we will factor out b squared from the terms b squared a and b squared c, and c squared from the terms c squared b and c squared a. Let's also work on the denominator a little bit. So let's expand the second and the third parenthesis. So we get b minus c, which is the first parenthesis, and the second and third parenthesis expanded will be ac minus bc minus a squared plus ab. Now, since a plus b plus c is equal to 0, then b plus c will be minus a plus c will be minus b, and b plus a will be minus c. Therefore, we can further simplify the numerator to minus a cubed plus b cubed plus c cubed minus 3abc minus a cubed minus b cubed and minus c cubed. We can also further expand the denominator to get abc minus bc squared minus a squared b plus ab squared minus ac squared plus abc plus a squared c minus abc. Looks like I made a mistake in this plus abc term here, so I'll just correct it. It has to be bc squared. Now we can simplify the denominator by canceling out the plus ABC and minus ABC terms. And we can rewrite the numerator as minus 2 times a cubed plus b cubed plus c cubed minus 3abc, and the denominator will be minus b squared c minus a squared b plus ab squared minus ac squared plus bc squared plus a squared c. So this is p. We keep it as is for now, and now we go and try to simplify q. We can rewrite q by finding the least common denominator, which is abc, and the numerator will be b times c times b minus c plus a times c minus a plus a times b times a minus b. Expanding the numerator q, we will get b squared c minus bc squared plus ac squared minus a squared c plus a squared b minus ab squared, and the denominator is abc. Now if we compare the numerator of q and denominator of p, we will see that if we factor out a negative sign from the numerator of q, it will become equal to the denominator of p. Now if we multiply p and q, the denominator of p and numerator of q will cancel out, and we will get minus 2 times a cubed plus b cubed plus c cubed minus 3abc, and then the denominator of q, which is abc. On the other hand, we also know that a plus b plus c is equal to 0. Therefore, if we move c to the other side of the equation, we will get a plus b equals to minus c, and now if we raise both sides to the power 3, we'll have a plus b to cubed will be minus c cubed. Expanding the left hand side of the equation will give us a cubed plus 3a squared b plus 3ab squared plus b cubed will be equal to minus c cubed, and then we can say a cubed plus b cubed plus c cubed will be equal to minus 3, and we factor out ab, so it will be ab times a plus b, and again we know a plus b is minus c, so this will be 3abc. Now let's substitute a cubed plus b cubed plus c cubed into the equation that we got for p times q. So we will get p times q equals to minus 2 a cubed plus b cubed plus c cubed minus 3abc divided by abc, and then a cubed plus b cubed plus c cubed is 3abc, so we get minus 2 times 3abc minus 3abc, which is minus 9abc divided by abc, and therefore it will be minus 9. Looks like we made a mistake somewhere. Let's see. Oh, okay. So the negative sign at the numerator of q was missed. So if we consider that, p times q will be plus 9 abc, and therefore the result will be 9.